Okay, this video was originally recorded with my microphone off by accident, so I'm attempting to re-record the sound now. And so this is about section 8.4, which is about compound interest. Einstein was quoted as saying that compound interest was the eighth wonder of the world. My mom thinks it's a scam. But in any case, it is where interest is charged on your balance that you borrow, and then that interest is added to your principal. And then the next month, they charge interest, so you have a higher principal, so you have a higher amount of interest charged on it. So it's compounded on itself. So here you have the formula, and you have A is the accumulated or final amount. So that could be the final amount that is owed after a certain period of time. Or it can also be the account balance if it's an investment. And then the principal is the original amount that you borrow, or it could also be the original amount that you deposit at the beginning. And then R is the interest rate per year. Make sure you always convert it to a decimal before doing your calculations. N is the number of compounding periods per year. So if it's monthly, N would be 12. If it's semi-annually, that means twice a year, so N would be 2. If it's annually, that's once a year, so N would be 1. If it's quarterly, N would be 4. And then T is the time in years. Okay, so suppose that $750 is borrowed at 7% interest, compounded semi-annually. Find the amount of money that will be owed after 25 years and how much interest was paid. Okay. All right, so P is equal to $750. And then it's 7% interest. So R would be equal to 0.07. And it's compounded semi-annually, which means twice a year. So that means N is going to be equal to 2. And then it's for 25 years. So T is going to be equal to 25. And then we're just going to put all of those numbers into the formula. So that would be A equals 750, open parentheses, 1 plus 0.07 divided by 2, close the parentheses, raise it to the power of N times T. So that is 2 times 25. So we're just going to put that into the calculator. And there you see the caret symbol that means to the power of. So that's used on a lot of calculators. called a caret. Sorry about the ads. Okay, so we're going to type it into the scientific calculator. So we got 750, open parentheses, 1 plus 0.07 divided by 2, close the parentheses. And then there is that caret button that means to the power of. All right, and I'm going to show you what would happen if. Okay, sorry about that. So this is what will happen if you don't put parentheses around your exponent. Oh, just kidding. This is with parentheses around the exponent. So yes, you have to put parentheses around the exponent, because if you don't, then it's only going to raise it to the power of 2 and then multiply the whole thing by 25. So, all right, so this gives us $4,188.70, which is a lot. That's the total amount that you would owe after those 25 years. And then I forgot to show and do the answer to the second part, which was how much interest is paid. But to figure that out, all you need to do is just subtract the principal from the answer that you already got. So it end up being $3,438.70. Okay. Number 2. Following the birth of her child, Sophia deposits $10,000 in a college trust fund where interest is 3.9% compounded quarterly. Find the amount of money in the account when the child is 18 years old. Okay, so she's depositing 10,000. So 10,000 is P, that's the principal. And then R will be equal to 0.039, and it's compounded quarterly, which means 4 times a year. So N is going to be 4. And then from birth to age 18 is 18 years. So T is equal to 18. And then we're just going to put all of that into the formula. So it would be A equals 10,000, open parentheses, 1 plus 0.039, close the, oh wait, divided by 4, and then close the parentheses, and then to the power of, open parentheses, 4 times 18. And then you would just put all of that into the calculator. So 10,000, open parentheses, 1 plus 0.039 divided by 4, close the parentheses, to the power of, open parentheses, 4 times 18. $20,109.35. So she more than doubled her money on that. Okay, number 3 says if you borrow $20,000 in student loans at 5.5% interest compounded monthly, how much would you pay at the end of 4 years? And how much interest will you pay? So P is 20,000 because that's the original amount that you borrow. And then R would be equal to 0.055, and it's compounded monthly. So since there's 12 months in a year, N would be equal to 12. And then it's for 4 years. So T equals 4. And then we're just going to put all of that into the formula. So A equals 20,000, open parentheses, 1 plus 0.055 divided by 12. Close the parentheses, raise it to the power of, open parentheses, 12 times 4. And then we would just put that into the calculator. So 20,000, open parentheses, 1 plus 0.055 divided by 12, close the parentheses, to the power of, open parentheses, and 4 times 12. $24,909.01. And that is the total amount that would be owed. $24,909.01. That's the total amount that is owed. And then how much of that is interest? So you borrowed 20,000. So the rest of that is the interest. So all you need to do is just subtract the principal from that answer that we just got. So make sure that you do not use the simple interest formula because that does not apply because this is not simple interest. So never use the simple interest formula unless it specifically says the word simple. All you got to do is just subtract the principal from the total. And that will give you the amount of the interest. So the interest in that case is $4,909.01. All right, number 4 says, how much must you deposit in an account earning 10% compounded annually in order to accumulate $9,000 in 8 years? So 10%, so that would be R equals 0.1. It's compounded annually, which means N is equal to 1. And you want to accumulate up to $9,000. So you want to end up having $9,000, which means A is equal to 9,000. And then it's for 8 years, so T is equal to 8. So this one's a little bit different because we're going to be solving for P. P is the unknown in this case. And I've also noticed on MyLabs that they like to simplify the formula whenever n is equal to 1. So basically they just take the n out of the formula. So you may see a different looking version of the formula like this. It's not a different formula, it's the same formula. They just simplified it by taking out the n because in this case, n is equal to 1. So you don't have to do it that way, but it's just an option. So just letting you know, so hopefully you won't be too thrown off by that when you see that on the MyLabs. All right, so this is going to be 9,000 is equal to P, which is unknown, so we're just leaving it as P, open parentheses, 1 plus 0.1, close parentheses. Okay, so I'm going to go ahead and put it over 1. And then close parentheses to the power of, open parentheses, 1 times 8. And then after that, we can go ahead and simplify it a little bit. Because 0.1 divided by 1 is still just 0.1. So this is basically what it would look like if you did use the simplified version of the formula. And then 1 times 8 is just 8. And then 1 plus 0.1, that just equals 1.1. So simplify it a little bit more. So there we just have 1.1 to the power of 8. Sorry, that's my little baby. Okay. So we have 9,000 equals P times 1.1 to the power of 8. So if we were to go ahead and put in to the calculator 1.1 to the power of 8, we get that number that has a whole bunch of digits after the decimal point, and we don't really want to have to round it off because that can throw off our answer a little bit. So what we're going to do instead is just go ahead and divide both sides of the equation by 1.1 to the power of 8. So 9,000 divided by 1.1 to the power of 8. That's what we're going to put into the calculator, and that's going to equal the principal. That's going to give us our final answer. So 9,000 divided by 1.1 to the power of 8. That's the best way to get the most accurate answer. So that's $4,198.57. And I've noticed on okay, so I've noticed on MyLabs it usually asks you to round to the nearest dollar. And in this case, it would probably ask you to round up to the nearest dollar, because if you round down at all, you won't reach that goal of 9,000. So even if it was only like 1 cent, you would go ahead and round that up just to make sure that you don't fall short of your financial goal. Okay, so next we have compounding continuously. So this is a slightly different formula, which is A equals P times E to the power of RT. So all these variables are the same as from the other formula. But E is not a variable. E is actually a constant. It's approximately equal to 2.718, but it does keep going forever after that as well, kind of like the same concept like pi. You know, pi is approximately equal to 3.14, but it has a bunch of numbers that keep going on forever after that. So E is a constant, and we're actually going to use the button on the calculator for E. Okay, so it says if you charge $350 on your credit card at 20.8% interest, compounded continuously, how much will you pay at the end of 6 months, and how much interest will you pay? All right. So P is equal to 350. And then R is going to be equal to 0.208. It's compounded continuously. So the time is 6 months. We want to make sure we convert that to years by dividing it by 12. So for now, we can just write it as 6 over 12 or 6 divided by 12. If you want to write it as 1/2 or 0.5, that's completely fine. It doesn't really matter at this time because we're just going to plug it in the calculator. So we're putting all this in the formula. A equals 350 times E to the power of 0.208 times 6 divided by 12, or we can put 0.5. And then we're just going to put that all into the calculator. So 350, and then we're going to locate E. So on most calculators, it's going to be right above the button that says LN. And you have to press the second function button first, and then press the LN button. And then that's going to give us E to the power of, and it even gives us the open parentheses that we need. And then we can put in the 0.208 times 0.5. So that's $388.36. So that's the total that's owed after 6 months. So A is equal to $388.36. And then they also wanted to know how much of that is interest. So all we have to do is just subtract 350 from the total. The $388.36 minus 350. So the interest is $38.36. All right. Number 6 says, Mr. Tone has $7,000 to invest. He has 2 options. Option A is 5% compounded continuously. Option B is 6% compounded daily, assuming 360 days per year. Not sure why they always tell you that, other than maybe there's 5 bank holidays or something like that. And then after 10 years, how much would be in each account and which option should he choose? So with either option, you're going to have the principal is equal to 7,000. And then you're going to have T is equal to 10, and that's going to apply for either option. And then for option A, you're going to have R is equal to 0.05. And it's compounded continuously, so we're going to use that last formula that we just talked about, which is going to be A equals 7,000 times e to the power of 0.05 times t. And then we would just plug that into the calculator. So it's going to be 7,000. Then we're going to press second ln. If you have a different kind of calculator, you should be able to just Google it if you need help finding the E on your calculator. Just Google for your specific model of calculator. So that was 11,500. $41.05. So then for option B, it's 6%. So it's going to be R equals 0.06. And that's compounded daily. And basically they want you to use N being equal to 360. So this is going back to the regular compound interest formula. So A equals 7,000, open parentheses, 1 plus 0.06 divided by 360, close the parentheses, to the power of, open parentheses, 360 times 10. And then we're just going to put that into the calculator. 7,000, open parentheses, 1 plus 0.06 divided by 360, close the parentheses, to the power of, open parentheses, 360 times 10. So that's $12,754.19. So option B is the one he should choose. Okay. Okay, so effective annual yield. So an account has a nominal rate of 8.6. So nominal means like the name of something, like they're naming you a rate of 8.6. So that is what they're actually using to calculate your interest, if it's like a savings account or something. However, with the, the rounding and the compounding and such, if you look back at your balance at the end of the year versus the beginning of the year, it's actually going to be a little bit higher percentage than 8.6. So the percent that you earn is actually a little bit higher, and the more often it's compounded, the higher that is going to be. All right, so find the effective yield rounded to the nearest hundredth of a percent with quarterly, monthly, and daily compounding. Okay, so for quarterly, that would be n is equal to 4. And for all of these cases, r is going to be equal to 0.86. That's what we're going to plug in. So y equals, open parentheses, 1 plus 0.086 divided by 4, close parentheses, to the power of 4, and then minus 1. And the minus 1 is not part of the exponent. So if you have another type of calculator that has the more what they call natural display, you may need to make sure that you use your arrow key to the right to get off of the exponent before putting in the minus 1. All right, so open parentheses, 1 plus 0.086 divided by 4, close parentheses, to the power of 4, and then minus 1. So 0.0888, we're going to round that to 4 decimal places for right now. So that way, when we change it to a percent, it'll be rounded to the nearest hundredth, which is what they asked for in the instructions. All right, so that is 8.88%. And then for monthly, that's going to be n is equal to 12. So y equals, open parentheses, 1 plus 0.086 divided by 12, close the parentheses, to the power of 12, and then minus 1. So we put that in the calculator. You can definitely just retype it, but I like to go in and edit what I already have. So like I can type a 1 over the top of the 4, and then I can press second insert to insert the 2. So that's just an option if you wanted to do it that way. So that gives you 0.0895. So that's 8.95%. And then next for daily compounding, we're going to use n equals 360. So y equals, open parentheses, 1 plus 0.086 divided by 360, close the parentheses, to the power of 360 minus 1. And just make sure the minus 1 is not in the exponent. So that's 0.0898. And that'll be 8.98%. And I find it interesting how much it goes up when you go from n equals 4 to n equals 12. And then when you go from n equals 12 to n equals 360, it only goes up like half that much. So like a little or less, a little bit. So it's kind of a law of diminishing returns. So increasing the number of compounding periods does increase the effective yield, but only to a certain degree. All right. So that's the end of 8.4.